Hello guys, in this video we're going to talk about the worksheet 11.1b level 2. So we're going to learn a theorem calling as the tangent from external point. It basically means that you have a point outside the circle, we call it as the T. And then if we draw two tangent lines from the circle to this point T, we have three properties going to be fulfilled. So the first of all is the contact point P to the external point T, and which is equal to the contact point Q to the external point T. So that's the first one. And the second one is the angle POT is going to be equal to the angle of QOT. So basically means the angle at the center are both of them are the same. And the third one is going to be the PTO is equal to QTO. So this means that the points at the external points is going to be the same as well. So if you want to prove this, quite easy, because we have what we learned last time is the tangent lines is going to be perpendicular to the radius. So first of all, we have OPT is equal to the OQT, which is 90 degrees. And together with the OP and OQ are the radius, and also the OT are the common side. So which means that we can using the RHS to prove that the triangle OPT is actually congruent to the triangle OQT. So these three things are the following properties from the congruent triangles. So then we can try to do the question 1. So in question 1, we have three tangent lines and at ABC respectively, but you don't have the center, so we try to illustrate this as a center, and then we connected center to C together with B as well. So we can see that Q as an external point, which means that the BQ is equal to CQ, which means that X is equal to CQ, which is equal to 2 cm. And then next, we can say that we have the PB. If we connected the OA, you can see that the P is actually the external point, so we have the PB is equal to AP, and then we say PB is equal to 5, and then BQ is equal to 2, so Y should be equal to 7. So that's question 1A, and then we try to do question 1B as well. So TP and TQ are the tangent lines, so we can say that we have the angle here is equal to 22 degrees. As we told before, we have the external point. We have the tangent from the external point. Then we can say that this angle are the same, and the angle at the center are the same, and the length are the same as well. So first of all, x just equal to 12, and then y is equal to the angle at the external points, which is equal to 22 degrees. And then we can say that this angle is z as well. So how can we say that? Or we can using the tangents perpendicular to the radius to say this is 90 degrees. So then we have z plus y plus 90 equal to 180. Then we can say as y is equal to 22. So z is equal to 180 minus 90 minus 22, giving the answer should be equal to 68 degrees. Okay, so now we can try to do question 2. In the figure, we have TP and TQ as the tangent, and we have PTO, this is equal to 34, and we're trying to find out what is x. So if this is 34, which means that the OPT, what is OPT? OPT is actually equal to 90 degrees by using the tangent. It's perpendicular to the radius, that what we learned last time. And then in the triangle OPT, we have POT, and then plusing the other two angles is going to be equal to 180, isn't it? So we have the angle POT plus the angle OTP plus the angle TPO is equal to 180 by using the angle sum of triangle, so that we can say that the angle of POT, which is this angle, which is equal to 180 minus 90 minus 34, will giving you this is equal to 56. Okay, so now we can say that's the QOT. Where is QOT? QOT. So QOT is this point. So this angle is actually same as POT by using the tangent from external point. So we can say angle QOT equal to the angle POT, which is equal to 56 as well. Then that's the tangent from external point. Okay, so we have the total thing. This is equal to the angle of POQ. Angle of POQ is just equal to 56 times 2, giving the answer of 112. So we can say this x. We can use the angles, angle at the center twice angle at the circumference, isn't it? Because this angle at the center is watching this arc PQ, and then this PQ is being watched by this x as well. So we can say that the x is equal to 112 divided by 2, back to 56 degrees. Then we can say this is by using the angle at the center twice angle at the circumference. Okay, so now we're trying to do question 3. And in the figure, we have PA, PQ, PC are the tangents. So PA, PQ, and QC are 3 tangents to the circle at A, DC respectively. And first of all, we have this angle is 120, and then the APD is equal to 46. So this is equal to 46. What we want to find out is the angle of CDQ. So how can we find out this angle? So first of all, if you realize that this is a cyclic quadrilateral, isn't it? Because we have 4 points on the circle and then they're all connected together. So ABCD is a cyclic quadrilateral, which means that the opposite angle plus this angle is going to be 180 degrees by using the opposite angle cyclic quadrilateral. So first of all, we can say that the angle of ADC plusing the angle of ABC is going to give you 180 degrees by using the opposite angle cyclic quadrilateral. So we can say that the angle of ADC is equal to 180 minus 120, giving you 60 degrees. So this is equal to 60 degrees. So is there anything else we can do? So the next thing we can say that is PA equal to PD, isn't it? Because this is the external points from the center, and there are 2 tangent lines. So we can say that the PA is actually equal to PD. So we can say that the PA equal to PD by using the theorem in this worksheet, which is tangent from the external line, point. So now we can say that this is an isosceles triangle. So we have the angle of PAD is equal to the angle of DPA. Sorry, it's PDA. So these 2 angles are the same. PAD and PDA are the same by using the base angles isosceles triangle. So we can say that the angle of PAD is equal to 180 minus 46 divided by 2. And this one is using the angle sum of triangle. So this is equal to what? 180 minus 46 divided by 2, giving the answer is 67 degrees. 67 degrees. So which means that this is equal to 67. Then we can using the angle at a straight line to get out what is the angle CDQ. So the angle CDQ is equal to 180 minus 60 minus 67, giving you the answer is equal to 53 degrees. So we can say this is by using the angle at a straight line. Okay, so that's for question 3. So now we can try to do what is question 4. So question 4, we have in the figure, we have AP, AD, they are the tangent line to the circle. So A is our external line, and then we have the C is on the point on AD is here, such that BPC is equal to 28 degrees and PCD is equal to 150. So what we want to find is angle PAB. PAB is here. So PAB is actually here. Then how can we do this one? So if you want to do this one, we can think about a way. So for example, if you want to find out this one, which means I have to understand what is this 2 point. And these 2 angles are actually the same. Why? Because AP is equal to AB by using the tangent at the external point. So then how can we find out this 2 points? So this point is actually, if you consider about this triangle, this is the external point by using this angle plus this angle. And how can you find out this angle? Is just using the angle of straight line. So first of all, we need to find out this angle PCB. So we have angle PCB is equal to 180 minus 150, giving you 30 degrees by using the angle at a straight line. Okay, so that is equal to 30 degrees. And then we can using the exterior angle. So we can say that the angle of PBA is equal to 28 degrees plus 30 degrees, giving you 58 degrees by using the external angle of a triangle. And then now we have this is equal to 58. And then this APB is equal to 58 as well. So as we have AP equal to AB by using the tangents from the from an external point. So can you see that? This is the external point. I have two tangents, which means that the external points to the contact point of the circle, they are the equal. So we have AP equal to AB. So now we can say that the angle of APB is equal to the angle of ABP, which is equal to 58 degrees. By using the base angles isosceles triangle, then we can say the angle of A, or PAB is actually equal to 180 minus 58 minus 58 is equal to negative 64 degrees by using the angle sum of triangle. That's it. Okay, so question 5. So in the figure we have PQ, QR, and then PC, and then PR. They are the tangent lines. We have 3 tangent lines outside the circle, and then we have the PQ. This tangent is 6 cm. We have this QR is 8, and we have this is a 90 degrees. So what we want to find out is the length of PR and then PC. So we want to find out PR and PC. So how can we find it? So if you want to find this, PR is quite easy, isn't it? We're just using the Pythagoras theorem, sorry. So PR is actually equal to PQ squared plus the QR squared by using the Pythagoras theorem. So this is equal to 6 squared plus 8 squared, then you can get this is equal to 10. This is quite easy. So now if we let PA is actually equal to PC, isn't it? What's the reason for that? We can use saying this is the tangent from the external point. So we can say that what is AQ? If PA is actually equal to X and PC is equal to X, which means that AQ is going to be equal to 6 minus X, isn't it? And then QB, as AQ and QB are the same, because the tangent from external points, the distance from the external points to the contact point to the circle is actually the same. So QA equal to QB. So we have the QB is equal to 8 minus X as well. And this one we are using the tangent from external point. So now we can say that both of them adding together are the same. So this AQ is equal to 6 minus 8, and then this QB is equal to 8 minus X. No, this QB is just equal to X as well, isn't it? So this QB is equal to 6 minus X as well. It's equal to 6 minus X as well, as this AQ is equal to QB. Sorry, I think we are asking about this B minus R. So this QB is going to be equal to 6 minus X as well. Then we can think about what is BR. So BR is actually equal to 8 minus the QB, isn't it? So now we can say that the BR is equal to 8 minus QB, which is equal to 8 minus 6 plus X, giving you 2 plus X. But 2 plus X is actually equal to what? 2 plus X is actually equal to, if this is equal to 2 plus X, then how can we do the rest? And then we can say that this PC is equal to X as well, right? Because at first we set the PC equal to X. And as PR is 2 plus X, which same as the CR is 2 plus X by using the tangent from external point. So we can say that the CR plus the PC is going to be equal to 10 cm, which is the PR's length. And then the CR is going to be equal to 2 plus X. And then the PC is equal to X. So it's equal to 10. So X is going to be equal to 10 minus 2, which is 8. 8 divided by 2, giving you 4. So X just equal to 4. Okay? So in this question, we try to set a variable here, and we're just using a whole circle, a whole triangle to come back from this PR by using the X as the variable to solve it. Okay? So try to think about the last questions. We have in the figure TP and TQ. They are the tangent line to the circle P and Q respectively. And we have the ROST, that is a straight line, and then the PRT is equal to 35 degrees. What we want to find out is the angle PTQ. So this angle is PTQ. So how can we find out this angle? So first of all, if you want to, there's a center, so we probably need to use it. So we try to link about this tangent back to here. So we link the we link the P to O and we link the Q to O. As the tangent is perpendicular to the radius, so we can try to write down this first. And after that, we have these two lines of the radius, isn't it? So this is going to be equal to 35 degrees as well. So when we have these two angles, which means we have this exterior angle, when we have this exterior angle, which means that we have this angle, and then actually the blue part, the angle T, is just the double of this angle because using the tangent from an external line. So we just write down the whole thing. First of all, we can join. We need to join out OP and OQ. Then we can say that the OP is equal to OR. They are the radii. And then we can say that the angle of RPO is going to be equal to the angle of PRO. So we can say angle of RPO is equal to the angle of ORP or PRO. They are the same. So because this is an isosceles triangle, you can say this is the base angle isosceles triangle. So this is equal to 35 degrees as well. So we can say that the exterior angle POT, so the angle of POT is equal to 35 plus 35, giving you 70 degrees. This is using the exterior angle of a triangle. Then we say this is 70 degrees. Then we can using our angle sum triangle to get the angle of PTO is equal to 180 minus 90 minus 70, giving you this is equal to 20 degrees. So this is using the angle sum of triangle. And then we say that the angle of OTQ is equal to the angle of PTO by using the tangent from the external point. So once again, this angle PTO is equal to the angle of QTO because this is actually the point at the external point, and this is from the tangent. So we have the tangent from external point to say that they are equal. So our required angle PTQ is actually equal to 20 times 2, giving you 40 degrees. Okay, so that's for this worksheet. If you have any problem, just